Okay, so creating multiple features from one column, right? There's always more than one way to skin a cat, and here we're going to look at the multiple ways to skin a feature. So the example that I'm giving here is that, we just worked with dividing something by tenure. So the way that we could look at blog visits could be either the number of blog visits by tenure, or we could also look at just, have you ever visited the blog? 1, 0. Both of those could provide information and be used for different contexts, or one may just have a stronger relationship in the model. So you create all these features and then you start building a model, and the one that gives you the best success criteria, whether that's your AIC or your BIC or whatever model criteria you're using for the type of model that you're building, you want to have a number of different features at your disposal so that you can try putting those into the model and seeing what works best. Let's look at our customer table again. All right, so let's create a feature for ever visited the blog, yes, no. So we can have the total number of blog visits. We can have blog visits divided by tenure, and we can have ever visited the blog, yes or no. So select ever visiting blog, which is actually the total count of times they've ever visited the blog. Let's do how many times they're visiting the blog per year. These numbers are much smaller than total login, so I feel like if we tried to divide ever visiting blog by months, we'd end up with really small numbers. And so we'll do, since first conversion date, we'll get rid of this 12 so that it's in terms of years. Cast ever visiting blog. Bum, bum, bum. Okay, so we're not going to cast this as an integer. We'll just do how many times they're visiting the blog per year. And let's make sure that our parentheses all line up, which they do. And so we'll do blog visits per year. And then we'll also do case when ever visiting blog greater than 0, then 1, else 0, and as ever visited blog. And this time that column is actually correct. This is from the customer table. And so let's take that. Okay. And so there are people who have never visited the blog, and so they have 0 blog posts per year. And their total number of visiting the blog. So let's do this as total blog visits. So now that column will look correct in this query. So when we create our final table, we're going to, of course, name it correctly. So now we have 3 features, right? And they're all slightly different, and they are all potentially useful to us. And we'd find that out when we go to model which one is the most relevant. Whether somebody just visiting the blog means something about that person or gives us some information, or whether it's how frequently they're visiting that blog on average, or whether it's just, you know, the guy who's visited the blog 200 times, which probably that's the type of thing that we'd need to be careful about. That's bias, right? We'd be putting a variable in there that's actually most often, not in all cases, but it's going to be probably correlated with people with higher tenure will have a higher total blog visits. Okay, so that's one example. Another example is, because we're going to be building out the full data set soon, we want to look at how we might bring stuff over. Let's do a join and bring some information over from another table. So let's just look at our tables again. And this is really what my life looks like when I'm working with data in SQL. I write all these select statements out, I look through the data, I figure out what I want to do, and then I start doing it. Okay, so let's look at these guys and find a good feature to bring over. Oh, it's not web scarping data. Oh man, I'm all about the misspellings today. And so any SQL Server browser that you use too is going to give you those errors with some context on what the problem is. And that's why I like to write my SQL queries in SQL first, and then I might go and put that query in Python. But if I was to try writing the query in Python, I'm just going to get back that I had no rows. I'm not going to get that error that gives me context into what it is I need to fix. So when you have to do some detective work on what's wrong with your query, it really makes sense to be in SQL, even though I understand that, you know, it's really popular and cool recently for people to say, oh, I do all my SQL in writing all my queries in Python, but really just from a standpoint of it being practical and having more information, it makes more sense to do it in SQL. Okay, so let's see. Okay, so this was a good one. So build services wasn't a unique table, right? Select, count, customer ID from build services, select, count, distinct customer ID from build services. Okay, we're gonna look at these two guys and the results of that will... Okay, so they're not distinct. So we can, let's write some notes. So we haven't talked about, this is how you comment things out. Oh, that's how you comment things out in Python. This is how you comment things out in SQL. So let's see. We want to maybe create a feature for people who have had more than one build service. Maybe we'll also create a feature for total build services. So we're getting it to that we want the join to be unique so that we don't end up with multiple rows for those couple dupes. It might not be worth it under normal circumstances, but if there was a larger difference in the number of unique customers to dupes, then this would absolutely make sense. And then, so since these are one-time things, it doesn't really make sense to standardize this by tenure or some other time measure, because it's not like these people are paying for build services 30 times, right? It's not, you know, how much they're spending on average per year, because there's only a couple of them. So, you know, people who had more than one build service, and then maybe a Boolean for ever had a build service. Okay, so that is one column. It is, what was it? The paid column in build services. Yep. Okay, so, and we're going to make 3 features from that and append them to the customer table. So we're going to select some paid as taught build services from customer as cust join build services build on build.customer ID equals cust.customer ID. And so this is actually a left join, right? Because we know that there are plenty of people that are in the customer table that don't exist in the build services table. So, and if we run just this, we're going to get only the sum, but we also want to get everything from the customer table. So cust.star, paid doesn't need an alias because it doesn't exist in the customer table. You only need an alias in front of a column that you're calling if SQL won't know which column you're referring to. So customer ID is in both. So if that was up in the select statement, it would need to have the alias in front of it, which it does because we have cust.star. Okay. We also want to group by customer ID because that was certainly not what we wanted. Okay, so let's go over. And we see that the total build services is mostly null, which we know. So let's do where paid is not null. Okay, and so we see this is going to be a sum. Let's see who that customer was. That was customer ID 4704. So let's look at him and see if he actually had 2 build services. Select star from build services where customer ID equals 4704. Yes, so he did have 2. And I could tell because the build services typically weren't over 1,000. Okay, so that came through correctly. If we wanted to, we could say case when okay, and so obviously here too in the original query, we have a lot of nulls that we'd have to, in the next, when we go to put the total data set together, we want those to be 0. We don't want those to be nulls. And we could do that with an update statement where we learned about inserting data into columns. We could just say update that column, set those nulls equal to 0, and then it'll leave everything else looking fine. So right now we have the sum of paid, and we were going to do, okay, so we have total billed services, and then we also wanted, have you ever had a billed service? Okay, so that should work. Let's take a look. Okay, and we'll go down. And right, so we still have that where statement, and all of these are 1 because these people obviously did have billed services. If we comment out this where statement, okay, now we can take a look and we see that people who had nulls for build services now have zeros in did you ever have a build service? What else did we want to build out? Ever had a build service? Oh, people with more than 1 build service. Okay. So we could do that with count paid. As number of build services. Okay, let's run this and see what we get. Okay, let's go over. Number of build services is 0. Let's see. We'll put our where statement back so that we're only seeing for people who at least had 1. And then there's the 2 for the guy that had 2. All right, perfect. So now we've looked at how we want to think about features and how they can be represented in a number of different ways to give us information.